Hello again, everybody, and welcome to this class about the atomic structure, in which we will be covering the four points. We will start with the elements and atoms, and we will see inside the atom. We'll talk about the numbers of nucleons, the atomic radius, and the ionic radius, and we will finish by talking a little bit about the isotopes and their properties. As you can see that in the world, every substance is made up from chemical elements, and each element has its own chemical symbol. These elements cannot be broken down further into substances by chemical means. And we can say that some of them are found on their own nature, such as nitrogen and gold. However, others are found in combination, okay, which means that we find them as compounds. In this image here, you can see the structure or a simplified structure of the atom, in where we can find the nucleus, which is formed by protons and neutrons. Then we will find electrons which are orbiting. So this is the structure of the atom, and actually to know the different charges of those subatomic particles, scientists found that the electron beam, after passing between two charged plates, is bended a bit toward the positively charged plate, which means that the charge of the electron beam is negative. And while doing this for the neutrons, they found that the beam of neutrons does not deflect, while the beam of protons has been deflected toward the negatively charged plate. And here we can mention that the deflection of electrons was more important compared with the deflection of the protons, which means that the mass of the electrons is negligible in front of the mass of the protons. So from this image here, we can see that the nucleus is formed by protons and neutrons, which have a mass which is very important compared with the mass of the electrons. So from that, we can say that the mass of an atom is actually concentrated within the center or in the nucleus. Good. Now we can actually represent atoms by two numbers. Okay, the nucleon number, or what is also known by the mass number, and we refer to it by the word A, and the atomic number, which is equal to the proton number, and we refer to it by the letter Z. And actually, the number of subatomic particles, which means electrons, protons, and neutrons, can be determined given their atomic number, which is the proton number, and the mass number. And let's see this example here for aluminum. So for aluminum, its mass number is equal to 27, while its atomic number is equal to 13. This means that the aluminum atom is containing 13 protons and 14 neutrons. And this 14 is actually equal to what? To the mass number minus the proton number, which means 27 minus 13, which is equal to 14. So the aluminum atom will be containing 14 electrons. Okay, so as you can see here, that the atomic radius of an element is actually giving us an idea about the size of an atom. And the atomic radius of an atom can be calculated by dividing out of 2 the distance between the two nuclei of two covalently bonded atoms of the same element, which means that we will be bonding together two atoms of the same element, then measuring the distance between their two nuclei, then dividing it by 2, it will be giving us the atomic radius. And as you can see here, this is the periodic table which shows the trends in the atomic radius across a period and down a group. And we can see from here that the atomic radius is decreasing across a period and it's increasing down a group. And this actually can be explained by the fact that going across a period, we are increasing the number of protons, which means that we are increasing the charge in the nucleus, the positive charge in the nucleus. At the same time, the number of the added electrons is added to the same level of energy, which means to the same shell. This fact will increase the attractive forces between the nucleus and the added electron. So the atomic radius will decrease. Then, by going down the group, the number of electron shells is increasing. So those added electrons which are in the outermost shell, they will be having less attractive forces which attach them to the nucleus. So this is why the atomic radius become bigger. And for the ionic radii, we can see that the ionic radii increases with increasing the negative charge and it decreases with decreasing the positive charge. This also can be explained by the electron shell theory. So to make negatively charged ions, we will start with atoms by adding electrons. And while doing this, while adding these electrons, we will be keeping the charge or the positive charge in the nucleus the same. So those electrons will be added to shells which are very far from the nucleus. So the attractive forces, they will be less comparing with the atom. So this is what makes the ionic radii increase in the negative charged ions or in the anions. Actually, here we can see that the ionic radii decreases with increasing the positive charge. Now, to make positive ions, actually we will be removing electrons from the atom and keeping the same charge in the nucleus. This will affect the electrostatic forces to be more strong. So, ionic radii for positively charged cations will be small. Now we'll be talking about the isotopes, and actually those are atoms of the same element that contain the same number of protons and electrons. They will be having the same number of protons and electrons, but different numbers of neutrons. As you can see here, these are the three isotopes of the element hydrogen. The first one is actually containing one proton and zero neutrons. Okay. The second one is containing one neutron and one proton, and the third one is containing two neutrons and one proton. We can recognize from this image here that all of them actually are containing the same number of protons. So this is why they are called isotopes. And here we can mention that the isotopes have similar chemical properties and different physical properties. So for the similar chemical properties, this is due to the fact that they all have the same number of electrons in the outermost shell. So they will be reacting with the same manner with other elements. And for the difference in physical properties, this is due to the mass of the nucleus. So by changing the number of neutrons from an isotope to the other, we will be increasing actually the mass of the nucleus or the atomic mass. So this will be affecting the mass of our isotope, and also this will be affecting its density. Okay, so thank you for watching. Please don't forget to share, like, subscribe, and leave a comment. Thank you for watching.